but it'd be a lot easier to do this with two colors today. So either grab two highlighters or two different colored pencils. Alright, so take out those notes, get them labeled. Two colors today if you want two highlighters or two colored pencils so you can tell the difference between the colors. So maybe not light blue and dark blue. All right. You have about 30 more seconds to make sure you're all set up.
Remember, grab two colors, doesn't matter if they're highlighters or pencils.
All right. So first thing we're going to do is identify what is a conditional statement. Okay, so a conditional statement is a statement that can be written as, or a sentence that can be written if something, then something. Not all conditional statements are written in that format, but if we are, I'm going to use an if statement right now. If we can write them in an then they are a conditional statement. We'll work on that a little bit as we go. Okay? This if part is the before part. And for that, we're going to use the word hypothesis. So whatever's in that if part, that's that hypothesis. Where else do you use that word hypothesis?
Science.
Yeah, in science. What does it mean in science, a hypothesis? Like an educated guess. Yep. In this case, the hypothesis is going to be something that we assume happened. Okay? So we have our hypothesis, and then we have our end, and our end we call a conclusion. So we have our hypothesis and then our conclusion. And with our hypothesis, we're always going to assume this already happened or is happening. Okay, so in our warm-up when we said, if you forget you have to work and play video games, and none of you said, oh, I would never do that. Okay, when we talk about that and we're coming up with those consequences, we have to assume that that part did happen. So we have to put ourselves in that situation. Come on, Hal. All right, so for our notes today, we are going to identify the hypothesis and conclusion, And we are going to determine the truth value. I'm trying to fit that all in one line. And this is where I'm going to use colors. So I'm going to use, whenever I see hypothesis, I'm going to shade in the hypothesis with pink. And I'm going to do the conclusion in green. So with those two colors you picked out, decide which color is which. That way it's just a little bit easier to see. Alright, so we're going to do a couple examples here. Alright, our first example. Say if two angles add up to 180 degrees, then they are supplementary angles. If two angles add up to 180 degrees, then they are supplementary angles. Alright, so let's identify the hypothesis. What's our if part, our beginning part? Good, and when we do a hypothesis, we don't actually include that word if. So it's just the two angles add up to 180. If you don't want to use color, you could do like underline for hypothesis and for the conclusion. And just put an H next to that. That's my hypothesis. And then what is my conclusion? Good, they are supplementary. We don't actually include the word then. We just want that statement that follows the then. That's our conclusion. Now let's decide, is that true or false? So if we are given two angles right in front of you, you have two angles that you know for a fact add up to 180 degrees. Does that mean that they are supplementary angles? If you're not sure, yeah, they're in the flower box. If you're not sure, look back real quick, take out those cards. Oh my goodness, we skipped so many pages. Why? That was my bad, apparently. Must have just stuck together. Take out, find your flaps. Find your envelope. Oh my gosh. What is happening in my life today? Find that word supplementary. Alright, so supplementary angles means what? Yeah, so if I have two angles, the measures, they add to 180. It says I have two angles that add to 180. Does that make them supplementary? Yep. So is this true or false? True. so for this one, it would be true. All right, number 2. Why is this like not quite showing up the way? It's like not quite as crisp. Maybe the pink. All right, yesterday was the 30th. Then today is the 31st. So we're at the date here. If yesterday was the 30th, then today is the 31st. So what is our hypothesis? Good. Yesterday was the 30th. I'll put a little H there for hypothesis, we could. And the conclusion? Today is the 31st. So we have to imagine yesterday was the 30th. In our real life right now, was yesterday the 30th? No. But we have to imagine yesterday was the 30th. We have put ourselves in that situation. Does that mean that today has to be the 31st?
Can I sample when yesterday was the 30th, but the very next day is not the 31st? Yeah, maybe it's the first of a new month. All months end on the 31st?
Nope.
No.
Does anyone know a month that ends on the 30th? September. September ends. September, October, November ends on the 30th, right? Okay. So is this always going to be true? No. So if it's not always true, if we can come up with one counterexample, we're going to say false. And we're going to say why that is false. Okay, and our example was yesterday was September 30th. Okay, when it's September 30th, what's the next day going to be? October 1st. So that makes that false. Because September only has 30 days. So we know that when yesterday was September 30th, today is October 1st. All right, number 3. Sometimes when we have those conditional statements, they're not written in if-then form yet. Okay? So we have to sometimes write them in that if-then form to determine that truth value. Okay, so it might be something as simple as 6 plus 4 equals 10. Okay? Right now, we could determine that truth value pretty quick. But we need to write it in an if-then form, and we can think of it as like kind of a before and after. So or a first and second. What's the first thing we're doing in this mathematical sentence? Adding what? 6 plus 4. So if you add 6 and 4, I'm going to just do the numbers. We're supposed to write out the letters, or write out the names, but that's okay. If you add 6 and 4, then what? Yeah, it'll give you 10, then it equals 10. So we want to practice when we see things that aren't always written in that format, 6 plus 4 equals 10. We want to think about them as an if-then. What are you doing first and then second? So now that we see that, what is our hypothesis? Yeah, you add 6 and 4. So we have to assume that we had 6 and we had 4. Maybe it's 6 of something, 4 of something, or we're just strictly adding numbers. And we're adding them together. That happened. What is this sentence telling us happens after that? Must happen after. It equals 10. When I add 6 and 4, must it always equal 10?
Can you think of a situation where you could add 4 of something to 6 of something and it's not 10?
So, is this true or false? True. I boxed my first answer, but now I'm not boxing my answers, and now it's bugging me.
Maybe box the trues because it's like final, but the false no because you're adding to it.
Look at that. Solved it. Problem solved. All right, number 4. Last one for today. This one's kind of a lot of writing because we're going to have to rewrite it. Okay. Everybody would be 2 feet taller on Saturn. Everybody would be 2 feet taller on Saturn. First off, what's Saturn? A planet, so not on Earth. So if we were on Saturn, everybody would be 2 feet taller on Saturn. So we want to think about this as an if-then statement. So our if has to be the first part. What is happening that's happening first? Is everyone first getting 2 feet taller? Or are they first on Saturn? We're actually on Saturn first. It's not saying if you were 2 feet taller you'd have to move to Saturn. It's saying that we're on Saturn. So if everyone was on Saturn, or everybody was on Saturn, let's do everybody since we already used that word. If everybody was on Saturn, So that's the part that happens first in that situation, even though in the sentence it comes second. So that implied it's happening on Saturn. So if everybody was on Saturn, then what? Then everyone would be 2 feet taller. Right? What is our hypothesis? Everybody was on Saturn. Yep. So that's our beginning. We have to assume that happened. Everyone is now on Saturn. We all traveled. We all space traveled. We went to Saturn. What's going to happen once we land on Saturn? Everyone just instantly gets 2 feet taller. True means it's oh. If it's false, we have to come up with a counterexample. We have to come up with proof.
So what do we think? True or false? How do you know? You can't even breathe. So you can't go to Saturn because you would die. How do you know that when you get there you don't shrink though? It doesn't say you have to be alive. Or I mean grow. It doesn't say you have to be alive, it just says you're bigger.
There's no like proof that.
It's do we have proof saying that this isn't true?
No.
No. We have to assume that people are on Saturn. Is there anyone currently on Saturn? No. So do we know that they wouldn't grow 2 feet taller? Mm-mm. So we actually have to say that this is true. Until someone goes to Saturn and comes back and is like, I didn't grow 2 feet taller, I stayed the same, or I shrunk. Until someone goes there with proof, we have to assume that this is true. Even if scientifically we're like, that doesn't quite make sense.
And those of you who have taken science, I think we talk about hypothesis in science, right? And the idea of a theory that you're making your best guess until you prove it wrong, right? A hypothesis is, this is what I think will happen, and it's true until I test it and show that it's wrong.
Okay, so a little note here is if the hypothesis is crazy. Okay, it's something weird. It's something that hasn't actually happened. Okay, if that hypothesis is crazy, no matter what the conclusion is, as soon as that hypothesis is weird, our answer is going to be true.
What that really means is not just the crazy hypothesis, but if you can't find even one counterexample, you have to default to true.
Okay, so in order for it to be false, you must have a counterexample, or must explain a counterexample. So you must have that proof showing why it's not true.